just using Pythagorean theorem. So this one is going from the point 1, 1, is what is called the, I can't spell, initial, to the point 5, 4. That is what is called the terminal point. That's where it stops. It terminates at the terminal point. Now, one way we can write this vector is in what's called component form. Component form means I'm going to take the change in the x's and then the change in the y's. And that's going to give me a resulting value that's showing how far I went from left to right and up and down. So I'll end up with values at the end. And that's going to give me my vector. And we do write vectors with this lovely fancy parentheses. Anyway, so for the vector I just drew, the x value where it stopped started at 1. The y values ended at 4 and started at 1. So right 4 and up 3. Now to be equivalent, I would have to have another vector that is in the same direction and has the same magnitude. But equivalent does not mean that they're exactly the same. So what if I started a vector with an initial value here? To be equivalent, it would also have to go right 4, 1, 2, 3, 4, and up 1, 2, 3. It would have to go in the same direction and have the same magnitude. Oh, I did not count good. I think I was just off on my spacing. So to be equivalent, they'd have to have the same direction and same magnitude. So this other one, let's call him U. U would also be a 4, 3 because it's exactly the same. Now how would we combine two vectors? So I have vector A is going downhill. Let's make vector A be like that. And vector B is doing this. If I wanted to take A plus B, I would take this one, A, tip to tail with B. And this resulting vector is going from here, from where we started at the very beginning, so it goes through A, then all the way through B. This vector here would be A plus B. And then I could count how far I went horizontally and up. But if I was given A and B in component form, so let's say A was the vector, let's say 3, -4, and B was the vector 10, 7. If I wanted to add those together and I was given them in component form, I would just add the components. And we do see that A would be quite long and not as tall as B was. vector that was twice as big as A, so twice as long. What do you think I would do to find that? Well, I would just double those components. And 3 times B, ooh, let's make it a negative 3B. So it would change the direction completely. It'd be going down and it'd be quite longer. It'd be negative 30 and negative 21. Now I need to talk about the magnitude. We talked about magnitude just a little bit, and that's the length of the segment. But I want to show you the notation for magnitude. So A was 3, negative 4. That means it went right 3, down 4. The symbol that's used for magnitude looks like an absolute value. It's kind of these double bars. And the way I would find that, so let's think about it in terms of Pythagorean theorem. I'm going to take that horizontal distance squared, vertical distance squared gives me the hypotenuse squared. So it is just going to be the square root of my horizontal distance squared. Oh, that one. Now let's see what happens if I do the magnitude of twice A. We just found twice A. What's going to happen to that magnitude? So I'm going to do 6 squared, horizontal distance squared, vertical distance squared. So I got the square root of 36 plus 64, the square root of 100, which is 10. So if you double the sides, or the horizontal and the vertical distance, it makes the magnitude also double.